This is Professor Pelton. This is trigonometry. This is Chapter 3, Section 2, Law of Sines. This is Part 1 of 3. Okay, so in Part 1 we did right triangles. Now we're going to cover the next couple sections the oblique triangles, which are the non-right triangles. So basically it's any triangle that does not contain a right angle. And if you're an oblique triangle, you're one of two cases. You're either acute or an obtuse triangle. If you're an acute triangle, all three of your angles are acute. Whereas if you're an obtuse triangle, you have two acute triangles and one obtuse angle, which makes sense. You can't have more than one obtuse angle because it would be more than 180 degrees. Okay? So as a result, since we are not a right triangle, SOHCAHTOA does not apply. So therefore we have to implement the oblique cases, which are either law of sines or law of cosines. So in this section we'll be covering law of sines. In section 3 we'll be covering law of cosines. And all of them fall into one of these categories, which are all the permutations of A and S, which stand for sides and angles, which are used in geometry for the triangle congruencies. So basically we have two ones that are problems. So if your car breaks down, who do you call? AAA. What do? They come and pick up your ass and tow it backwards, right? So in geometry, those didn't work for the congruency cases, and the same thing here. They're going to cause problems because if you have three angles that do not make a unique triangle, it is an unsolvable triangle because it'll give you an infinite number of triangles. So if it's AAA, you can't do the problem. If you have more angles than sides, you'll be using law of sines in this section. When we get to section 2, section 3.3, we'll be doing more sides than angles. You'll be using the law of cosines to solve the non-right triangle known as an oblique triangle. And finally, in trigonometry, you can do the ass and ass backwards case with law of sines or cosines. We're going to do law of sines, and there'll be some problems when we get to it. But first we're going to cover the cases where law of sines is only used, where we have more angles than sides. So first off, why does the law of sines work? Well, there's two versions of the law of sines. There's this version, and then there's this version. Because they're all proportions, it doesn't matter whether the angle goes on top of the sides, as long as you're consistent for all three. So you can take any oblique triangle and draw the altitude, and as a result I'll get two right triangles as a result. So then I can do my SOHCAHTOA. So if I do SOHCAHTOA using angle A, that's going to be H over B. And if I do SOHCAHTOA for B, that's let's see here, H over A. So if I solve for H in both cases, that would be multiplying by B on both sides. That's going to be B times sine of A and A times sine of B, because I had to have multiplied by A on both sides, and I had to have multiplied by B on both sides, which would have canceled. So now I have two equations both equaling H, thus they must equal each other, correct? As a result, so therefore B times sine of A equals A times sine of B. And we can divide both of these by the sides, which is AB and AB. Cancels the B on one side, cancels the A on the other side. So I'm left with sine of A over A and sine of B over B. Okay? So the result is we've proved that the ratio holds. The difference being is you can turn the triangle and draw the altitude down from B, or turn it down from A, and you'll get any of the other variations on the ratio, because whenever you do that you make right triangles. Okay, let's do some example problems. The obtuse case is very similar. We're not going to prove it, but you just essentially draw the altitude on the outside. Okay, first example. In the textbook problems and the test problems, the diagram will not be given. You'll be expected to draw it. But the format of the question will still be the same. So if we look at the diagram given that has all the placement of the various angles and sides given, the case that I have here is angle, angle, side, or side, angle, angle, which is the same back and forth. And you can clearly see it's a side, an angle, angle, or an angle, angle, side, depending on which direction that you go. What's important here is you can't go this way and skip an angle to get to another angle. You can never skip to an angle to get to another angle, skip a side to get to another side. Okay, so you had to have gone this way or this way. Okay, it would have been angle, angle, side, or side, angle, angle. Okay, that's the basic premise of geometry with congruencies also, so that hasn't changed. Okay, so we want to find side A, side B, and angle B, which are missing here. Okay, so first off, angle B is going to be 180 degrees minus the other two angles, which are 46 and 63, because the total must be 180 for all three angles. So that's going to leave me with 71 degrees. Okay, now we can do the remaining ratios to find the sides. So the only ratio I know at this point is this one right here. You can either put the angle on top or the side. It is up to you. We'll put the angle on top. So that is the sine of 63 over the 56 equals the sine of 46 over A, if we want to solve for A first. But it doesn't matter whether we solve for A first or B, it doesn't matter. There's no particular order to these. So we will cross multiply. So we cross multiply, we get A times sine of 63 equals 56 times sine of 46. So we need to get A by itself, so we'll divide by the sine of 63. So cancel. So A is approximately, again, since you're typing in degrees, then you have to have it in degree mode in the calculator. You'll get 45.2 inches. So that is our first answer. Again, the only ratio we know is the ratio for C, which is the sine of 63 over 56. You should not use the answer you just found for A, because that is an approximation, right? It is not an equals. You don't want to use an approximation to find another measurement because it'll be way off. Okay, so we'll do the B now, which is the sine of 71 over B. We'll cross multiply. It gives me B times sine of 63 equals 56 times sine of 71, and divide by the sine of 63. So that gives me B is approximately 59.4 inches. Okay, let's put those in the diagram real quick. So that's about 59.4 inches, and that's about 45.2 inches. And what you should notice here is the longest side is across from the biggest angle, and the smallest side is across from the smallest angle. And the medium side, of course, is across from the medium angle, and this should be consistent with all triangles, whether they're right or not. Pause the video, try the student problem. Okay, for the student problem, this is pretty consistent that the diagram will not be given. So draw an arbitrary ABC triangle where the angles are capital and the sides are lowercase. So we know this is the 64 degrees, and we know the C is the 82 degrees, and we know side C is 14 centimeters. So we do not know B, and we do not know A. Okay, so when I read this, I cannot go C to B because I can't skip an angle to another angle. Can't do that. So when I read this, in fact, I have to go this way. So that, in fact, is a side angle angle, or an angle angle side, depending which way you go. Okay, So the only ratio we know here is the ratio of C. So that's the sine of 82 degrees over 14. That is the only ratio we know. If we want angle B, we're going to have to do angle B is the 180 minus the 82 plus the 64. So angle B gives us 34 degrees. Okay, there we go. Alright, so now we can find our remaining sides of A or B. It doesn't matter which one you do first. So the sine of 64 goes with the A. We'll do the other one now. Sine of 82 degrees over 14 is our only ratio we know. And sine of 34 degrees to B. So those are our two comparisons, the only ratio that we know to find A and B. Okay, so we'll cross multiply. So we cross multiply, get A times sine of 82 equals 14 times sine of 64. And B times sine of 82 is 14 times sine of 34. And sine of 82 and sine of 82 and sine of 82. Cancels, 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 cancels. So A is approximately and B is approximately. So again, since we're typing in degrees, you need to put degrees into your calculator as the setting. So that'll give us a 12.7 centimeters and a 7.9 centimeters. And again, put those in our diagram. So that's about 12.7. And this one is about 7.9 centimeters. And check with the relative sizing again, that the smallest side is across on the smallest angle and the biggest side is across on the biggest angle. So those are our cases of angle, angle, side, side, angle, angle. Let's try the next ones. Okay. Alright, so next one's here. We have an angle, a side, and an angle, which is the same both ways. An angle, a side, and an angle, no matter which way you read it. So, that's this case. Alright, so again, we have one angle missing. So if we do the math here, angle B is the 180 minus the 50 plus 33.5. So angle B is in fact 96.5 degrees. Okay. So the only ratio we know here is the B ratio of side to angle. So that's the sine of 96.5 degrees over B. And we can compare that twice, so we'll write that again over here. Sine of 96.5 degrees. That came out pretty terrible. Over B, which is 76. I don't know why I wrote B. It's actually 76. Okay, so that is our only known ratio. Now we'll do our unknown ratio. So the first one is A, or B, or C, doesn't matter. So we'll do A, so that's the sine of 50. So it goes with A. And C is sine of 33.5. Okay, so that gives us our A value. Do the same thing over here, cross multiply. C times the sine of 96.5 equals 76 times sine of 33.5. And divide by the sine. cancels, and C equals. It's a little tight in there, but you can get it nonetheless. Okay, so on the A value, we'll get 58.6. And on the B value, we get 42.2. Okay, let's fix that 8. That's a 58. Alright, so pause the video and try the student problem. Okay, student problems again. Book problems and test problems will not be given the diagram. So we'll draw an arbitrary ABC triangle where A is 40 degrees and C is 22.5 degrees and side B is 12. So another angle, side angle is the given. So we can find the angle B by doing our simple math for the triangle angle theorem. So angle B is the 180 degrees minus the 40 plus 22.5. So thus angle B would be 117.5, right? Okay, so now we just need side A and side C. And the only ratio we know is the side A to angle A ratio. So that is the sine of 117.5 over 12. And we'll compare that twice. So first we'll compare it to A. Then we'll compare it to C. Okay, so we'll do our cross multiplying. So when we cross multiply, we get A times sine 117.5. It's 12 times sine of 40. And divide by the sine. So A is approximately, and we get there 8.7. We'll box that up. And cross multiply here, I get C times sine of 117 equals 12 times sine 22.5. And divide by the sine. So C is approximately, and I got there 5.2. Okay? Alright, so whenever you have more angles than sides, you're going to use law of sines to solve for the missing angles and sides using the known ratios and not using any of the estimated values. That is the end of part 1.